All right, Baeyer-Villiger. This is now too cool. This is too cool. Before you look at all this gobbledygook, and you need to know it, before you look at all this gobbledygook, look what we have here. R, carbonyl. At the end, look what we have. Watch this. R, carbonyl. We have intercalated. Ooh, I love that word. This is a good biology word. Intercalate. And we have intercalated an oxygen. Wow, that's so cool. That means we can take something like this. Let me start over again. Nope, I want to use a different one. That means we can take something like this and do a Baeyer-Villiger oxidation, which you're going to write as that, and get this. Wow, that's so cool. Right? You see what I did? Here's carbon 1, 2, 3. Here's carbon 4. Here's carbon 1. Here's carbon 4. Look at that. That's so cool. Now we can do different things with this, right? Which is what you ought to be thinking for synthesis. Lots of things we can do with an ester. Okay, and think of where this came from, right? So this is your synthesis game. This came from over here. This is going to over here, and this connection is really gonna give you some magic. All right, that's awesome. So let's look at the mechanism. And yes, you need to know this mechanism. So we're gonna have a nucleophile. So we say this is in a different section. This is no longer carbon as nucleophile, right? It's now, I guess, an oxygen, but it's different than the other one, so let's look at it. We have a peroxy acid. So remember this moiety? That's a peroxy acid. This pair of electrons comes to that carbon, pushes those electrons up, no big deal, that we can expect. You have to memorize which oxygen it comes from, I guess. Okay? But now once it does, then you get, look at this, like a little 5-membered ring here. Do you see that? You have to bring that around and deprotonate that guy. You see it? He deprotonates. That's just a proton transfer. Okay? Then, and this is the one that's going to be hard to remember, I think. In my view, this is the long one. Look at that. It's a concerted mechanism. 1, 2, 3, 4 things. This one I'm going to argue is the one to remember, the hard one. Okay? You get a rearrangement. So the big deal is that this alkyl group, look at this, this alkyl group switches from being on this carbon, to this oxygen. Sorry. You see that? Look at the switcheroo right there. You knew how to switch. You knew you had to switch, right? Because you have an oxygen in between. Where does it come from? It comes from right there. That's where it comes from. Wow, very cool. All right, so that's the mechanism. You need to know it, practice it, and then we're going to practice what we can make with this guy. So which step in this equilibrium is most likely the slowest? Which is most likely the slowest and why? Think sterics, like where are things? Okay, where are they? Are they close by? And think about energies, right? That's what activation energy is. Okay, and then also make a comment on why the last step is not reversible. All right, so let's look now here at what's going on here. If you have, if the carbon is asymmetrical, Use the following chart to determine which migrates most readily. Where a hydrogen migrates most readily and a methyl group migrates least readily. In other words, where's the oxygen going to go? Do you see what I'm saying here? It's either the oxygen's either going to go in there or in here. So let me say this is option 1, this is option 2. Option 1, making this easy for myself, right? I'm going to first of all draw it like that so I can see everything. And you know there's really going to be a bond angle there. That's not going to be linear. So this really is equal to I'm just going to turn everything over. 1, 2, 3, and X. 1, 2, 3, and X. Okay, that's good. Yeah. Or option 2. And I'll put the intercalated oxygen over there, which is really the same thing as right? Okay, so which is it going to be? Have a look here. There's your answer. All right, and draw the mechanism out here with this reaction, and then consider it a good day's work. I think that's it. Yep, that's it. All right, good luck. See you next section.